the webinar schedule. I tried to divide it up so that the divisions in the classes made sense. You can attend all 6 of them or just the ones that interest you. Try to make them, they kind of build on each other. The idea again is to have an hour presentation. Some might be less than an hour, some might be a little more. And then the second hour we'll leave the webinar open for questions and comments. During the first hour, please limit your questions to our topic tonight, which is digestive physiology. Don't ask about worms. Second hour, you can ask about worms. Also, use the chat box to tell me if you're experiencing any problems, volume, just like you told me you couldn't hear me anymore when we went to the poll. If you'll let me know about those things, that's the other use of the chat box. Again, make sure you write your question to everyone so that everyone can see it, because Jeff's not going to see it if it goes privately to someone else or privately to me. So just make sure you share everything. Again, not just questions, but if you just have something you'd like to share. We want everyone to be able to interact. Yeah, the chat box did go away when the audio went away because I went to that poll and the chat box wasn't on that poll. I've mentioned previous, but I just want to let you know the PowerPoint presentations, the one tonight and the ones for the other webinars, will be posted to a website called SlideShare. You see the URL up there. You can access the presentations as well as a lot of presentations on sheep and goats. You can view them if you want to download them. If you want to use them for your 4-H club or something like that, you simply need to register with that website. The webinars will be recorded. I already started the recording. I'll do some minimal editing, and those will be posted to my sheepandgoat.com website. There's the URL. It's just a page called Recordings. You can also access it pushing it on an icon, and I'll be sending more information just to remind people how they can access this. If you're interested in the whole series but you got a conflict 1 or 2 nights, you'll be able to view them. If you want to, again, share them with a 4-H club or share them with someone else who's not able to participate, they will be recorded. So there's the topics, consecutive Thursdays. I'm going to be the presenter on 4 of these. Jeff, I mentioned earlier, is the county extension agent here in Washington County, in the home county where my research center is located. He's going to do the session on feedstuffs, and the one on ration balancing is going to be Willie Lance. Willie is a county extension agent in Garrett County, county that gets all the snow. And then we'll always have someone kind of lurking in the chat room to try to help answer questions and really add to the discussion. I'll introduce myself. I think most of you know me. I've kind of been rambling for about 40 minutes, I think. My name is Susan Schoenian. There's how you say it. So I'm the sheep and goat specialist for University of Maryland Extension. My office is in Keedysville, Maryland, which is just south of Hagerstown, if you're familiar with that area, about 80 miles north of Washington, D.C., for those of you from other areas. We have a 500-acre research farm there. The specific research or work that we do pertaining to small ruminants has been goats for the last 7 years. We run a meat goat performance test with a big focus on internal parasites. A couple years ago, we started harvesting some of those goats and started doing some carcass work. And last year, we started feeding a group of goats. So we're going to compare the performance, the economics, and the carcass traits of pen versus pasture-fed goats. So we're really excited about doing that work. At home, I'm a sheep breeder. I have about 40 Katahdin and Katahdin crossbred ewes. I lamb in March, so I've still got a couple of months before I start lambing. The reason I thought a session or a webinar series on nutrition would be good, a couple of reasons. Based on last year's webinars, particularly the first one on lambing and keating, got a lot of questions about nutrition and feeding. And also we polled everybody. We did like a survey, and that seemed to be a strong interest on nutrition and feeding. And when you think about nutrition, it's probably the most important aspect of raising livestock. It's the biggest influence on their health and their productivity. It's the biggest cost of raising sheep and goats, 75%, I mean, at least. And then, of course, we all know that these feed costs, they were already a significant part of our costs. And I don't care why you're keeping sheep or goats. They're a significant cost. Those costs have gone up considerably, considerably. You know, grain prices have been going up the last several years. And I know in my area I have to buy hay from hay auctions, and hay is now very, very expensive. In fact, I think I'm back to the situation where grain is more economical than hay, believe it or not, at the prices that we have for grain. So the first webinar is on digestive physiology. This is kind of your science class. In order to properly feed livestock, I think we need kind of like a background and a basis to understand what's going on, to understanding how it works. And ruminants are fascinating. Their digestive system's very complex, and in no way are we going to get into the complexity of it. In fact, I want to remind you, my background is in applied genetics. I'm not a ruminant nutritionist, so I hope you don't ask me too hard of questions. We're going to talk about the basics, the basic concepts of ruminant digestion that can help us understand, well, what are the consequences when we do this or this, or why should we do this or this when we're feeding our small ruminants. So basically what I mean by digestive physiology is this is the process. You know, we feed our livestock, they convert that to substances that then their body can use to maintain itself, to grow, to produce milk, to do all those sorts of things. So that's what we're talking about. The physiology is kind of understanding the science of it. You know, we don't think of that when we're out there feeding our animals, but I think we need to understand, again, why things do what they do without going crazy over the complexity, because digestion, again, is very complex and even probably more complex in ruminants. So I want to start by talking about some different digestive systems, because again, I think that creates an understanding of the animals that we're feeding. And we start by usually classifying digestive systems by what the animal primarily eats, plant versus animal. And of course, we're going to focus on the herbivores because that's what our ruminants are. And of course, these are animals that eat primarily plant materials. Whether they're grazers or browsers, doesn't mean they never eat animal material, but they primarily eat plant material. And of course, that's our domestic farm animals, as well as a lot of wild ruminants, deer, moose, antelope, giraffes. They're all ruminants as well. It's a very diverse group of animals. And there are differences within these groups that we're going to talk about, because that also lends an understanding to feeding these animals. Of course, carnivores are our pets, typically our dogs and cats, and of course there's plenty of wild carnivores. That's predominantly all of our predators that we are concerned about for sheep and goats are carnivores. Again, it doesn't mean they don't ever eat plant material, but they primarily eat other animals. People always tell me that I'm a cat person, and they say, you know, when your cat's looking at you, he's really thinking, if you were smaller, I'd eat you. I hope that's not true, but these animals are meat eaters. And then the group that we fall into, which is an omnivore, where we eat a combination of plant and animal material. And our systems, whether it's our digestive system or the kind of teeth we have, the kind of senses we have, all it really relates to which of these categories we fit into. You know, I always get a kick out of the idea that, well, I don't want to eat. When I tell people, well, I raise sheep for meat, and they, you know, they don't like, oh, not everybody likes that idea. And I think, well, you know, I didn't decide to eat sheep. When they were made a prey animal. You know, all their characteristics are as a prey animal, and all the characteristics of my dog are as a predator. And those things were, you know, nature decided those things. Other omnivores would be a pig, whose digestive system is very, very similar to ours, which is why they're often used as a model. Chickens have a little bit different kind of digestive system, but they eat both plants and animals. And then rodents. Rodents are both a plant and animal eater. So that's our first kind of group that we look at. And then if we look specifically at how they process or digest their food, within the fermenter, or within the herbivores, we got ruminants, which is what we're focusing on tonight. And the primary characteristic of ruminants is they have a multi-compartment stomach. People always say, well, they have 4 stomachs. And in reality, it's not 4 stomachs. It's just a stomach that has multiple chambers, 4 chambers. In the case of a llama or an alpaca, we consider them a ruminant, but or actually we consider them a pseudo-ruminant because they actually only have 3 parts to their stomach versus a ruminant which has 4. The other group that's a big forage eater is horses and rabbits, but they're actually not a ruminant. They're actually really a monogastric, simple stomach. But we call them a hind gut fermenter. Not the coolest name in the world, but the cecum is part of their large intestines. It's the first part of the large intestine. It's very large, much more complex than, say, the one we have, and it performs the same function as the ruminant digestive system. It allows them to digest highly fibrous feeds. So that would be rabbits, that would be horses, and that would actually be rodents and rats as well. But they're technically a monogastric. And of course, a monogastric, again, it's what we are. It's what omnivores typically are. Pigs, chickens. And again, chickens have a little bit different digestive system than say, a pig, but they're still considered a simple stomach animal. Our carnivores, of course, fit into this area, the cats and dogs and the wild carnivores, and of course us. So, and what type of digestive system has a lot to do with how they process different feed ingredients. And when we consider how they do, it should tell us, well, you know, this is really what we should feed them. And so this table, and I found it from another PowerPoint presentation, didn't see any reason to recreate it, but it compares those 3 different animals with those 3 different type digestive systems, from the ruminant to the hind gut fermenter, which again has the ability to utilize very fibrous feeds, and the monogastric. And they're almost opposite, the monogastric and ruminants, in terms of what kind of feed they can utilize. You know, obviously ruminants were designed to eat highly fibrous roughage, and their system allows them to do that. And on the other hand, if it's really high quality feed, a monogastric is much more efficient at utilizing high quality feed. If we lived in a situation where feed resources were limited, which they are, of course, in a lot of other countries, it's far more efficient to feed monogastrics, pigs and chickens, to produce meat than it would be our ruminants. Of course, you know, from a standpoint of producing dairy products and fiber, we don't really have a monogastric that we do that with, but monogastrics for high quality feed are much more efficient. On the other hand, you know, on the other hand, we have, if we have highly fibrous feeds, we have pastures, we have this and this, it doesn't really make sense to put pigs and chickens on that kind of feed, other than maybe for exercise, because they're not nearly have the ability to utilize and to get nutrition out of those kinds of feeds. And it's not that we can't feed high quality feed to ruminants and that we can't put chickens out on pasture and pigs out on pasture, but it's just important to understand what they're more efficient at utilizing, what they're able to utilize. That's just the main point of that. Again, nothing's there's not like big lines between them, but this is actually what they're designed to do and what their system's capable of doing. And of course, like everything man gets a hold of, we always like to try to manipulate it or kind of change it. So when we compare the ruminant versus the monogastric, the major division in digestive systems, everything's the same except the stomach. You know, it starts at the mouth and it ends at the anus and the rectum. That's all the same. The pancreas, the liver, the gallbladder all contribute to the digestion process. What is different is the stomach. So the ruminant, again, we have 4 chambers to that stomach. The monogastric, we have a simple, basically glandular stomach. So that's the difference. Everything else is going to be very much the same. Now, within the ruminants, we can also classify or differentiate them. They are not all the same. And they basically classify them into 3 areas. First one's what we call a concentrate selector. And this is what you'd call a browser. They select plants that are highly digestible, high in starch, proteins, fats, low in fiber. These animals have less of an ability to digest cellulose. Less of an ability. Classic example of the concentrate selector is the white-tailed deer. We call goats browsers, but they're not, because a concentrate selector essentially is a browser, but a goat's actually more intermediate. Your true browser, your true concentrate selector is the white-tailed deer. They have a deeper mouth, narrower, deeper mouth, and a tongue that allows them kind of to get those high quality plant parts. The other end is the grass or roughage eater, which is what sheep are. They have a highly developed fermentation system. Even though these are all ruminants, there's difference within these ruminants. So they have a better ability to digest the higher fibrous feeds. They don't need as high a quality as feed. They eat more. They got a wider muscle designed to eat more food. Cows, of course, would be even more so than the sheep in terms of this. And then again, I mentioned the goat fits in the middle. When given a choice and have the opportunity, they will be a concentrate feeder. They will eat the most nutritious part of the plants. They will browse. But they also have the ability to utilize the same kind of forages and plants that sheep and cows utilize. So they kind of fit into the middle. And these differences will affect the anatomy of the digestive system. The roughage eater has the larger reticulum and rumen. The concentrate feeder has the larger abomasum. The goat fits in the middle. So we're going to talk now about the ruminant stomach. And some of this may be not new to some of you, but it's always good to talk about what is the basis of how all this stuff works. So there's 4 compartments or chambers to the ruminant stomach. The reticulum, the rumen, the omasum, and the abomasum. We make kids memorize these to when they do skill-a-thons and things like that. As I mentioned before, llamas and alpacas, which we technically call ruminants or small ruminants, are more of a pseudo-ruminant, and they have 3 parts to their stomach. They don't use complicated names. They just call them C1, C2, and C3. And I think mostly, and somebody can correct me if they're an alpaca expert, but I think mostly they kind of lack the abomasum. They have the same kind of rumen reticulum that's the large fermentation vat. They still, of course, need your basic true stomach, so they have the abomasums. So there are three parts to their stomach. Compared to sheep and goats, they don't need to eat as high quality a diet as sheep and goats. Now we're going to go through each of these sections. The first one is the reticulum. That is the first stomach. That is the first place the food goes after leaving the esophagus. They call this part of the rumen honeycomb because if you look at that picture, it's kind of honeycomb in appearance, and that's where it gets its name from. It shares some of the same function as the rumen in that fermentation occurs there. It has microorganisms. It's almost, there's not a lot of separation. In fact, a lot of literature that you read really don't list them as separate. They combine them because there's not a great deal of difference in these 2 organs. Food goes back and forth. The one thing that differentiates it is this is kind of the collection place for foreign objects. We don't hear much about hardware disease in sheep and goats, but this would be where you would have those objects and they can be removed with a magnet in cattle. They would accumulate in the reticulum. The reticulum also, because of its location, plays a key part in when the food is regurgitated, and rechewed and reswallowed, and also for expelling gas, because that's that's between the rumen and the esophagus. Also very important on the young ruminant, and we'll talk about that a little bit later. It can contract to its resting size. It really is an organ that can really contract, and again, because of the role it plays in those other functions, it's very important. The rumen, of course, is the one we think about when we think about a ruminant animal. The nickname is the paunch. It's by far the largest part of the ruminant digestive system. It's on the left side of the animal. Again, it's larger in the animals that are more capable of fermentation. Again, the roughage eaters composes a smaller portion of the concentrate feeders or the intermediate feeders. Essentially, it's a storage site for food, and of course, it's a large fermentation vat. And it houses millions, actually that should say billions of microorganisms. It's lined with, the epithelium of the rumen is lined with these finger-like projections that they call papillae. You can see the close-up of those, and these are needed for absorption. when a baby ruminant is born, he doesn't have any. That's something that develops as he gets older and as he begins to consume food. I actually have some pictures. We'll look at the young ruminant as it develops. An important part of the rumen and ruminant digestion is chewing their cud. You know, if you ask, well, what makes a ruminant, the two things are the multi-chambered stomach and the cud chewing. And a cud, of course, is a food bolus. So they regurgitate that food bolus, re-chew it, add saliva to it, and re-swallow it. What that accomplishes is it reduces the particle size of the feed, increases the rumen volume, which allows the animal to eat more feed. And when you think about a ruminant, again, especially the ones that eat a lot of roughage, the more highly fibrous feeds, they eat a lot. They have to eat a lot because those feeds aren't nearly as digestible. So that's why rumination is so very important. The next stomach, the third stomach, is the omasum. And if you look at the picture in the lower right corner, it has a bunch of folds or leaves. And so they've nicknamed it many piles. I've also seen where they call it the book or the butcher's Bible or things like that. They equate it to the look of a book. I think a lot less is known about what the omasum does than what the other ones do. Doesn't really have any digestive activity. It's primarily believed that as the food moves through this organ, it grinds the feed particles into smaller particles, removes moisture as it pushes its way towards the omasum, smaller part of the system. In this picture, it looks very similar in size to the reticulum, but it's not as big as the abomasum or as big as the rumen. The true stomach of the ruminant is the abomasum. That's its nickname, the true stomach. It's just like the stomach that we have, just like a monogastric, same function. Secretes gastric juices which aid in digestion. The picture in the middle shows an abomasum. I added the picture on the right kind of as a reminder. This is the point of attack for barber pole worms and some of the other stomach worms. Obviously they're called stomach worms because they attack the abomasum, but this is the site of attack for barber pole worms. And you can see in this particular picture there's quite a lot of them. This is the blood-sucking parasite that's going to cause anemia and protein loss in the ruminant. It affects cattle too, but primarily sheep and goats. So the rumen itself, as I mentioned, it's full of bacteria. It's an anaerobic environment, which means it doesn't need oxygen. Its pH is usually between 6 and 7, and pH is incredibly important to the rumen because when it gets too acidic in the rumen, we can have problems. So the pH is very important. Each milliliter of rumen contents contains 10 to 50 billion bacteria. That's just a close-up picture that I found on the internet of the bacteria. You have primary bacteria that break down the nutrients or the feed particles and the nutrients in the feed particles. Then you have secondary bacteria that their substrate may actually be the product of that initial digestion. They also is protozoa in the rumen, and also yeast and fungi are in the rumen. All of these things are in the rumen. And all this stuff we have too. We're just not designed, in quite the same way to have these huge populations. So there's a lot of different, not only are there a lot of microorganisms, but there's different kinds. And this just shows you different kinds, and what the different kinds are is what they prefer to, what their substrate is, what they prefer to digest or what they produce. If they're actually a secondary bacteria, then maybe they produce methane or convert to ammonia, that sort of thing. And so the diet of the ruminant affects the population of those microorganisms because, and we're going to talk about these things, and I think someone has asked a question about that, but diet's going to have a big effect on what kind of microbes are favored. And the pH also favors certain types of microbes. So again, the rumen is a fermentation vat. That's basically what it does. So it takes carbohydrates and breaks them down into sources of energy. It converts protein into amino acids. It synthesizes vitamin K and B vitamins. We don't need usually to supplement ruminant livestock with either vitamin K or B vitamins. What we commonly do is if we've got an animal that's not eating well and want to stimulate its appetite, it's very common to give B complex vitamins. Even though the rumen normally makes them, it's just very common to help stimulate that rumen is to give them like a shot of B complex vitamins. The rest of the vitamins, basically, they would have a dietary requirement for. Now, the main end product of this fermentation from the standpoint of carbohydrates is what we call volatile fatty acids. You very often just see VFAs, volatile fatty acids. This is where the ruminant gets its energy from these. Most of the energy, not all, but most of the energy, about 80%, it gets from these volatile fatty acids. And again, the fatty acids that are predominant are going to be affected by diet, by what we're feeding them. And again, we're going to go through each of those things. Almost 100% of the volatile fatty acids that are produced in the rumen are of these three types: acetic acid, propionic acid, and butyric acid. Acetic acid is usually in the highest proportion, followed by propionic acid, followed by butyric acid. And they're all kind of dealt with differently in the rumen. The only one that provides, converts itself to glucose is propionic acid. And very often we will feed diets to try to get more propionic acid in the rumen, a higher proportion of it, so we get more glucose, so we get higher production. So when we feed a concentrate diet, a higher quality diet, we will get more propionic acid at the expense of acetic acid. So we will increase production. When we feed an ionophore, and that would be Volatile or Rumensin, one of the effects of that, why it improves the feed efficiency, is because it increases the portion or proportion of propionic acid. Acetic acid is the most abundant volatile fatty acid. Its important role is in fat synthesis. It's the one that's dominant in a forage diet, which of course would be the most natural diet for a ruminant. So when a ruminant's eating predominantly forage, they're going to have the highest proportion of acetic acid, and to me, that's the most natural. But we're going to get a higher production when we increase the propionic acid. But if you see, I don't know if you can tell from the arrows that I'm using, one of the challenges of this, and a lot of the challenges of nutrition, is creating a balance. If I'm feeding dairy, well, any female that's producing milk, more concentrates are going to increase propionic acid and she's going to produce more milk. But because acetic acid is used in fat synthesis, I'm probably going to get a lower butterfat. That's very important if I'm raising dairy goats or dairy cows. But I'll argue it's equally important if I'm raising meat animals because my lambs and kids are going to grow faster on higher fat milk. So it's a balance. It's a balance. Propionic acid gives us higher production because of the glucose. Acetic acid gives us higher butterfat. And of course the dairy cow industry really is in great detail into this. And so again, what we feed them affects that. As far as protein metabolism, basically there's two types of protein, and every protein source, just about every protein source would have both kinds. So you would have protein that when it reaches the rumen is broken down in the rumen by the microbes. It'll be broken down into ammonia, amino acids, and peptides. Some of that microbial protein will eventually end up in the abomasum where it can be absorbed. Then you have what we call undegradable intake protein, and it goes by a lot of different names, but it doesn't get downgraded in the rumen. It gets to the abomasum where it can be absorbed, which is more efficient. So we're getting more protein in the animal if we can bypass the rumen. This protein is also called bypass protein. I think a lot of you might be more familiar with bypass or escape protein. We also may call it protected protein because it's not downgraded in the rumen. It gets to the lower digestive tract where it can be absorbed, provides protein directly to the animal. Now, if you want to increase the amount of bypass protein in the diet of your animals, and that is a common goal, these sources tend to be, again, they're high quality feeds and they tend to be more expensive. You know, we don't ever get something for nothing. If something's better, we pay more money for it. Traditionally, the best source of bypass protein were animal proteins, something like meat, meat and bone meal. Well, as you guys all know, with the mad cow thing and the scrapie thing, you can't feed meat and bone meal. And really, the only animal source is fish meal. I don't know how much feather meal is available, but the table shows you some feeds out there that have pretty good percentages of this bypass protein as compared to other sources of feed. And you can see by far, well, feather meal has the highest percentage, but fish meal is a very good source of it. Cornell University was a big advocate for including fish meal in the diets of both lambs and ewes because of the bypass protein. And you can get fish meal. And again, it's going to be expensive because not only is it high in bypass protein, but its overall protein is very, very high. Soybean meal is not a bad source of bypass protein. Distillers grains, which are getting more popular feed, not a bad source. You can just see what some of them are. A lot of what we call co-products. You know, as we use more grain for ethanol, we have these co-product feeds, and distillers grains is an example of that, and corn gluten is another co-product, and they have pretty good sources of the bypass protein in them. Crab meal would probably be like fish meal. I think both of them would smell. So how does the diet affect the rumen? This probably right here is the most important slide to think about, is for you to understand when you feed what things happen in the rumen. And so if I feed a high roughage diet, which I'm going to say is the most natural diet, the diet that the digestive system was primarily designed for, the animal chews a lot, chews their cud a lot, ruminates a lot. The food takes longer to pass through the system. We have a higher pH, but realistically you would probably say a normal pH, between 6 and 7. The bacteria that are favored when the animal eats a lot of fiber are the ones that digest fiber, those cellulose and that other group that's what substrate they prefer. They predominate in the rumen. Acetate or acetic acid predominates in the rumen on a high roughage diet. High roughage diet. If I switch over and have a high concentrate diet, let's say we had a feedlot where we had lambs in it, they are going to chew less. They're going to have less saliva in the system. Feed's going to go through quicker. They're not going to ruminate as much. The pH is going to be lower. It's going to be more acidic. We're going to favor those microorganisms that are starch digesters. We're going to favor that propionic acid. So we're going to create these changes in the rumen. Does that mean a high concentrate diet is bad? No, it doesn't mean it's bad, because here I'm assuming we've done it right. You know what I mean? We've not all of a sudden dumped a bunch of grain in front of them. We've given time for the rumen to adjust. But it's just important to know that they're very different rumen environment based on whether it's a high forage diet or a high concentrate diet. And realistically, a lot of times we're doing both. Very realistically, we're doing both forage and some concentrate if we need that concentrate for animals that have higher nutritional needs. Now our problem is is if we overfeed concentrates, or we abruptly shift to that grain diet or something else that's highly fermentable. A certain amount of that propionic acid is converted to lactic acid, but we will get a lot more lactic acid accumulate in the rumen and in the blood. The pH is going to drop, and with the pH dropping, we're going to change the type of microbes we have. And the bottom line is it can be fatal. Basically here we're talking about acidosis, grain overload, and it's not caused by the basic idea of eating grain, because again, there's nothing wrong with feeding grain to ruminants, but you gotta give the rumen time to adjust. If you all of a sudden start, like when I start feeding my ewes in late pregnancy, I don't all of a sudden start giving them a pound of grain. I take practically the whole month before lambing to gradually increase them. Feed changes should be very gradual over a couple of weeks. If you bring lambs or kids in and you want to start feeding them grain, it just needs to be very gradual. And that's just plain common sense. I mean, it happens to us too when we abruptly... I still remember the time I visited China and I ate real Chinese food. There wasn't a thing wrong of it, but it was a lot of vegetables, and it was very different than the diet I eat here. Well, I don't think I need to tell you what happened. Changes in the diet need to be gradual, and in the case of a ruminant, you know, the natural diet is that high forage, so we just need to be careful. We don't need to say, hey, you can't feed grain, because to be honest with you, it's hard to get, in some cases, the production they need and to meet their nutritional requirements without some higher quality feed. But we want to be careful because, and we're going to talk about some of the problems that we can have. Pellets are concentrate, yeah, unless they're like ground hay. You know, we're going to talk about some of these problems. So here, this is a case of acidosis. We can also get bloat. There's some different things that we can get when that increase in grain comes too swiftly. Another aspect of ruminant digestion is the production of gases. They're the primary byproduct. And everything in life has a byproduct. Whatever you produce, there's going to be something you need to get rid of. They produce carbon dioxide, methane, and a few other gases of minor consequences. In order for that animal to stay healthy and even to survive, it needs to get rid of these gases. Primarily, it gets rid of them by, of course, the fancy name is eructation. Basically, we're talking about burping and belching. Some is lost through respiration. Very different from people. The belching, that reflex is very well developed. It's, you know, you can't even really tell that it's occurring, but it's constantly occurring because, again, it's as natural as chewing their cud, is they have to get rid of this gas. The way it moves, you know, up through the system, the rumen contracts, there's pressure for the esophagus, and there's a sphincter that has to close. If they can't expel the gas, the disease we tend to get here is bloat. And of course, that can be life-threatening. Many animals will die of bloat. And there's different kinds of bloat. There's ones that occur pastures that are high in legumes. There's you know, grain or a kind of a free gas bloat. Every year when my ewes first start grazing spring pasture, I'll get some of them to bloat. Not that they're at a life-threatening stage, but you can see they're really big on the left side. And so there's some different ways it can cause bloat, but it's basically a failure to be able to expel that gas. Now, the one thing that's significant and attracting a lot of attention, and not necessarily in a good way, is the fact that one of the gases that they produce is methane, and methane is a greenhouse gas. And it's been estimated that domesticated ruminants account for up to 28% of the global methane production. I think the estimates are probably all over the board. But with a lot of the anti-agriculture and anti-animal agriculture rhetoric, you know, there's concern about this. Even though it's a natural process, it's still a contribution to greenhouse gases. And the more animals we have, the more food they eat, the more methane will be produced. So how can we reduce methane and still maintain production? There's a lot of research that's being done in that. Well, basically, the higher, if you feed the feeds that are higher in digestibility, and again, this gets back to a lot of the concentrates, you will produce less methane. But I think more important than that is improving animal productivity will reduce methane production. A perfect example is I have 100 ewes and they produce 100 lambs, and you have 100 ewes that produce 200 lambs. They may produce the same amount of methane. The ones with the 2 lambs, we may get more methane, but per unit of production, that more productive animal is better. Will produce less methane when we have higher productivity. Instead of maintaining 200 ewes to produce 200 lambs, we only need to maintain 100, and therefore we produce less methane. So a lot of our environmental things, really, personal opinion is we just need to make decisions that increase productivity, because an increase in productivity means we need less animals to produce the same amount of product. A lot of the research that they're looking at some really interesting things. They've discovered that there's some genetic differences. I think this research was with cattle on how much methane they expel. There's different feed additives that they have fed that will reduce methane production. So while in general higher quality feed results in less methane production, there are actually feed additives, like tannins are a perfect example. Tannins, which condensed tannins, which can have a kind of an enthelmintic effect on worms, are also going to help with reducing methane. So that's a product that really has a lot to offer the industry. And in Australia, they've actually developed the vaccine. They've immunized the sheep and they produce less methane. Other approaches to the methane issue are a lot less popular. They've actually tried to impose taxes. They call them the fart tax or the flatulent tax. They haven't tried that in this country, but they have tried it in other countries, and as you can imagine, it's not met with a great deal of it's not met with success. And so I think really the idea would be to develop systems that reduce methane production and maybe provide incentives for producers to do that. But this is an issue that just in today's times is not going to go away, and that is unique to ruminants, even though it's a far cry from the contribution of the other greenhouse gases, carbon dioxide. Anything, as I said, man gets a hold of, we want to alter. So we understand how the digestive system works in the ruminant, and of course we understand how it works in the monogastric, and in particular the rumen. What are some ways that we can alter that we can change that to make the animals more productive, more profitable? And here's just some examples, and again, a lot of research is being done in this area. A primary way to improve production, at least from an additive standpoint, again gets back to the ionophores, the Rumensin and Volatile. Those products have so many positive effects on the ruminant animal. You know, they're labeled or approved for sheep and goats as coccidiostats, which is very important. But you know, whether it's altering the fatty acids, protecting the protein so that it gets to the abomasum, you know, reducing the chance of bloat, it's kind of an all-positive thing. The only thing negative about ionophores is they are technically an antibiotic. And while in this country you are allowed to use them under natural production systems, the one developed by USDA, if you want to say, you know, if you don't want to use them, you know, and in Europe you can't use them under organic, or you know, you can't use them. They've made it hard to use any antibiotics at all. So the Europeans has actually been looking at other things that will basically have the same effect on the rumen, or similar effects on the rumen. Microbials or direct fed microbials. Here we're talking about probiotics kind of stuff. Yeast. A lot of work that's going into that. We've actually done some of that work here in Maryland. The research that was done in Maryland with lambs and goats really didn't show any benefit to feeding these products in terms of feeding like a healthy animal, and did you get better feed efficiency or more growth. The hypothesis may be that if animals are doing well, it maybe won't improve their productivity, but for animals that are compromised, you know, animals that you're taking to the show, bottle babies, you buy a group of lambs and put them on feed, animals that are compromised, that maybe these products would definitely have a benefit. Europeans are looking at essential oils and different plant extracts, again, condensed tannins being one of them. And the idea is that these, let's quote, natural things would be able to do the same things as the antibiotics. While ionophores aren't really an antibiotic in the same sense as something like penicillin or tetracycline, we are basically moving away from that kind of thing from a consumer standpoint. And if we can find replacements that are natural but do a lot of the same things, I think everyone will be well served. We just need time to do the research and to replace those. The protected nutrients, the idea here is that, again, getting back to that bypass protein, what can we do to keep that protein or that fat, too, from being degraded in the rumen to get it to the abomasum where it can be directly absorbed and directly utilized by the animal? And there's different ways that they can do that, but also, again, we have differences in the feeds themselves, the fish meal being higher, the corn gluten meal being higher in bypass protein. And increasing the amount of lipid, lipid is 2.25 times more energy in fat than there is in carbohydrate or protein. So that's a way to increase energy in the diet. We typically don't feed ruminants a very high fat diet, only about 3, 4, 5% versus monogastrics that we feed a lot more fat. I noticed somebody earlier asked a question, or Jeff answered it, about sodium bicarbonate or baking soda. A buffer is essentially just trying to keep that rumen from getting too acidic. I've found that that's somewhat popular among goat people to feed sodium bicarbonate. We had a 4-H goat project one year that we felt we had lost, and because of the nature of when they were fed, lots of kids being involved, we kind of did it as a as trying to maybe an extra protection. But the sodium bicarbonate, again, will keep the rumen from getting too acidic, because when it gets acidic, that's when we run into problems. The last thing I wanted to talk about tonight was the young ruminant. The young ruminant. They're very different than their moms, and then an animal with a fully functional rumen. Because when a baby ruminant is born, they have a rumen, they have a reticulum, but it really doesn't work. It's very small, it really doesn't work. If I showed you a picture of the digestive system, mature animal versus baby animal, you would see a significant difference, because the abomasum, the true stomach, would be as big as all the other parts put together, as I have in that text. Okay? When they're babies, that's what it is. They're completely different. They're a little monogastric. Okay? They need highly digestible food. Their stomach is designed to digest milk. Their abomasum is designed to digest milk. The forestomachs, the rumen, the reticulum, they're designed to eat the solid food. So when he's born, he doesn't really have that ability. He's all abomasum. And what you have, and we've got a little graph this shows here, there's a esophageal groove reflex, which is what we've traditionally called it, but the new sheep nutrition book published said it's actually called a ventricular groove. But what it is when an animal sucks, and not, like sucking on a teat or a nipple, that causes that reflex. And as you can see in the picture on the left, kind of creates a tube that, instead of that milk or any liquid going into the rumen, it bypasses it and goes directly into the abomasum, which is where you have the enzymes to digest lactose, to digest milk proteins in the abomasum. So that baby ruminant, when he sucks on a bottle, sucks on his mom's teat, that activates that reflex, and that milk goes right into the abomasum, which is where it needs to go. Now, if we tube feed an animal, which we have to do sometimes, that goes into the rumen. So that milk that you force feed is not going to be utilized as quickly as that which they get from sucking. And I also think that, personal opinion is that you definitely need to be real careful about not overfeeding them, because again, it's going into the rumen, and so and you could cause indigestion. Now, you'll read some things on the internet, and this may be more with cows, but that an adult animal that doesn't occur anymore. But one of the things that concern that we have nowadays is the fact that it still does occur, and in an older animal. But like if we drench an animal, we use a syringe, And let's say we just use a regular syringe and not one with that long metal nozzle, and we put that worming medicine into the mouth, and we don't stick it into the esophagus. That stimulates that same reflex that that baby ruminant has, and that deworming medicine bypasses the rumen and goes into the abomasum. We don't want that. We don't want that. So some of the strategies for deworming sheep and goats is to make sure you deposit that drug over the tongue into the esophagus. Okay? You don't put it in the mouth. And that's why it's essential to use a drench gun or an oral dosing syringe that has a long metal nozzle that allows you to get it over the tongue. It's also one of the challenges if you use like a paste dewormer. It's because it's harder to get that back over the tongue. So just keep in mind that that's what could happen. And so that's going to reduce the effectiveness of that dewormer, is if it doesn't go directly into the rumen. The other strategy we've often recommended with the dewormers that have the greatest problem with resistance, which would be Safeguard, valbazen, and ivermectin, you've often heard to fast them before you deworm them. And what that does is if they're fasted, it's going to stay in the rumen longer. And in the very least, it's better to deworm an animal that's on a forage diet where the rate of passage is slower than on a concentrate diet, because again, that medicine is going to stay in the rumen longer and be more effective. And again, that's an issue with the ones that we have the high degree of resistance to. We usually don't necessarily recommend you fast them and do all these things for Sidectin and levamisole. But this is what occurs with the baby ruminant. That milk goes straight into the abomasum. As that ruminant starts to eat food, that rumen is going to develop. It's going to develop those papillae. It's going to get populated with bacteria. One of the interesting things I've read about the rumen getting inoculated with bacteria is when the mama grooms her baby, that's kind of another way that the bacteria gets into the system. One of the more interesting things that kind of defies logic is that the rumen will develop faster, and that's often our goal. I'm not going to say it's everybody's goal in everybody's production system, but usually you want to develop that rumen as quickly as possible. You want to turn that animal into a ruminant so that it can utilize highly fibrous feeds. And it's ironic that grain develops that rumen quicker than forage. That's, to me, it's just ironic. Here they're designed to be forage eaters, and yet it's that grain that's going to help develop that rumen quicker. There's some real interesting pictures on one of Penn State's websites of the rumens of calves at different stages and at different diets. And this particular one shows what the rumen looks like, and this is the inside of the rumen, based on what that calf is eating. And this is when the calf is 4 weeks old. It's not going to be any different than in lambs and kids, except maybe the fact that a lamb, I know my lambs develop their rumen probably quicker than a lot of calves. But if you just give the animal, if it's just getting milk, and of course that's hard just to have milk unless it's in a system where it can't access anything, but at 4 weeks you've really got no development there at all. If that animal has access to hay, and I don't suppose it would be any different than if it was access to pasture, you got some development in terms of color, but you really don't have any papillae. If that same calf is on grain, look at the difference, how much quicker that rumen is developing. And again, the quicker that rumen is developing, the quicker that animal becomes a ruminant, the quicker it can be fed the diet of a ruminant. And to me, what's important about this is weaning. If you want to wean early, and by early I might mean 50, 60 days, and this might be more apropos to sheep people or lamb producers, but you probably need to be creep feeding if you want to wean early, so that you get a rumen like the one on the right. Just milk's not going to do it. Like say you were feeding a group of orphan lambs and they were just straight milk diet, it's not going to do it. Okay, at least not in a quick time. And think about orphans too. Like In the dairy sheep business, they tend to wean them when they're like 28 days of age. I don't mean wean from their mom, I mean wean from the milk replacer. Well, those babies, one, better be eating enough solid food to replace the milk when they wean them, but just as important, you want that rumen developed. And so again, if you want to wean early, you want to probably creep feed. Now, if you're not going to wean early, you're going to go 4 months, or maybe even going to do a natural weaning, it's not as critical. But I would never want to grow lambs or kids on pasture and wean them at like 50 or 60 days. They're going to need, if they're just on a forage diet, they're going to need longer to get that rumen developed. And how can you tell when it's developed? Well, you'll see those little cuds chomping away. I think I creep feed my lambs, and I think they develop when by the time they're a month old, they're chewing their cuds. And somebody asked a question about probiotics. Yeah, there's products that probiotics is putting bacteria into the rumen. There are things out there that people will market to try to get that rumen developing. But if you need or want the rumen to develop faster, you should creep feed with grain. A lot of people that, getting back to these sheep dairies, they actually don't even give the lambs forage, because when they wean them, they like forage, so when they wean them, they'll eat mostly forage, and then at 28 days of age, that's not enough to sustain them. So they actually won't even, it'll be only milk, creep feed, and then they wean them onto grain. And eventually they'll put forage in the diet. But just sometimes the dynamics are interesting with all this, and I just find it quite ironic that grain develops the rumen quicker when the ruminant is a forage eater. I think that's the last slide for this evening. We're approximately at an hour. There's some dairy goats in Brazil. And so our next webinar, we're going to look at nutrients and nutrient requirements. I always like to remind people that goats and sheep and people too have no requirements for specific food. None. It's all nutrients. And by nutrients we mean things like protein, carbohydrates, vitamins, minerals. My mom always teases me I don't eat enough vegetables, and I say, what am I missing in my diet? And I may well be missing something in my diet, but so we're going to talk specifically about the nutrients, what they need, why they need them, and then how those requirements vary, whether it's a goat or sheep, a dairy goat, a dairy sheep, a meat sheep, a Nigerian dwarf, an alpine, a Suffolk, a baby doll Southdown, a pet. We feed them all the same, but those requirements are going to be different based on the animal, and even based on other things like the weather or the climate or that sort of thing. How much activity they have, how far they have to travel, things like that. And then after that, Jeff's going to talk about the feedstuffs. So the feedstuffs that provide the nutrients. And then after that, then we're going to talk about, well, we know what the nutrients are, and we know what they need, and here's the feedstuffs. Well, what do we do now? What do we do now? How do we actually take this knowledge to feed our livestock? And we'll talk more in general terms in that session, and then we'll actually show you how to balance rations. And Willie Lance will do that. It's balancing rations is math. And a lot of people don't like math, but that's what it is. How much does the doe weigh? Is she pregnant? Is she lactating? How much milk is she producing? How many babies does she have? How fast do you want a lamb to grow? Things like that. It's numbers. You got to weigh feed. You got to analyze hay, or we can use book values, but it's all about math. And then, like I said, the final session will be on nutritional disorders. Some of the things we've alluded to tonight that mostly they're things that disrupt the rumen, but there's also other diseases that don't necessarily disrupt the rumen, but we're not feeding the right balance of nutrients and that sort of thing. I think someone was asking a question about creep feeding. That baby ruminant, again, needs highly digestible foods. Not what mom eats, unless mom's eating soybean meal and cracked corn. They need highly digestible, fine particles, things like that. And again, if you're going to wean later, then a slower developing rumen is okay. It's just, again, if you want to wean early, understand what it's going to take to get that rumen developed. And understand, too, that, again, look at this picture of these goats. These are ruminants. If we're going to change perhaps what's their most natural diet, we need to understand what it's going to do to their system. It doesn't mean we can't do it. We just have to understand how to feed this or that, and how their body is going to respond. You can technically feed sheep and goats practically all grain, but you got to do it right. And with a lot of byproduct feeds and a lot more different things to feed, we just need to be concerned about that rumen environment, that ruminant environment. The very nature of creep feeding is that they eat all they want. That's the very nature of creep feeding. But when they're very young, they do not eat a lot. They are basically learning how to eat. Learning how to eat when they're very young. That's as important as the nutrition. Like when they're 3 weeks old, they're not eating much grain. But the habit that they're getting into is very important. And will the kids overeat? That is why when we talk about feeding higher quality, more concentrated diets, we highly recommend vaccination for overeating disease. Basically Clostridium perfringens type D. You should vaccinate mom when she's pregnant, about a month before she's due. When the lamb and kid get their colostrum, they will be protected for 6 weeks or so, and then their immunity from the colostrum will start to go down, and then you would give them a vaccine. You would begin their vaccination at 6 to 8 weeks of age, 4 weeks later. But it's when you're creep feeding and you're starting that at a young age, again, vaccinating mom is what offers that protection. And where you run into danger with creep feeding is not that they overeat so much. If they've got it in front of them all the time, but let's say you let it run out, and then you filled it back up, that's where you can run into a problem. But if you keep it out there and you keep it fresh for them, again, they're not eating a large quantity when they're wee little. I don't think my lambs eat very much till they're about 6 weeks of age. And I have creep-fed goats, meat goats, as well as sheep. And I'd be giving you bad advice if I say it's going to be profitable for everybody, because you got to look at that, the economics of that. And when we start talking about practically feeding and balancing rations, economics is an important part of it. We're concerned about obviously meeting the animal's nutritional needs and a healthy rumen, but also about economics, particularly if you're a commercial producer. But even when you're not a commercial producer, I suspect you'd like to make, do things that make economic sense, at least reduce the cost of maintaining your hobby or your 4-H project. So economics is a very important aspect of feeding, and a lot of programs, computer programs, will actually be least cost rations. When people ask me about feeding this or that, I just break it down to what it costs. I mean, that's all I do. What does it cost? If it can deliver that, again, delivers a nutrient, if it can do it in a cost-effective way, the cheapest way, then it fits. But a lot of people feed kelp, and I'm not saying that's bad. I would just simply ask, is it the most economical way to get those nutrients in the animal? That's all I would ask. Or beet pulp, or soybean hulls. Is it the most economical to get the nutrition into